now I can just write that. Okay, so here n square pi square into h square divided by 2 pi square here into here 8 ml square, that is now n square pi square h square divided by 8, what is the 2 is there, 2 into 4 is 8 ml square into pi square. So pi square gets cancelled, so that is 8 ml square. Okay, so this is the particle, this is the energy of the energy value of a particle confined within the box. That is, we can say that it is a discrete box. So why we can call that discrete box? I said that, see, sin phi, I have considered that value only when b is equal to n pi by l, means there is a particular value, they are not continuous value. So that's why in case of 3 dimension, that is Ex will be nx square h square by 8m lx l square, Ey, similarly Ey. Okay, so and therefore the total energy will be, I can just write it, h square. Okay, so n square, I can just say that h square by 8m nx square by l square, I can just take that lx square then ny square by ly square plus nz square by lz square. Okay, so now this is h square by 8m, you can just see that here, this is the total energy. Now I told you this, so here, so this is the total energy of the equation here. So I can just say that here, this energy values, I can call this as a eigen value. This is called as what? Eigen value. Now this function, so what we got it, so here we operate it and we have just found it, no, this function is called as an eigen function. So now what is this eigen function and what is this eigen value? So we have to know what is eigen value and eigen function. Okay, so now before I just go to this, what is the solution here, now it is the right moment to say that what is this eigen value and eigen function. So actually, if you just, for a physics people in India, at least in India, physics people will only know the value, the meaning of eigen values and eigen functions. So the eigen, it is a German term. Why? Because this Erwin Schrödinger, he is a German guy. So he has termed this eigen value, which means that it is a proper value, or we can just say that proper characteristic value. Eigen value means function means proper characteristic function, and eigen value means proper characteristic value. Okay, so now this term eigen function and eigen value is a important terminology. That is, now I am just giving you the eigen function definition after I am deriving this expression. So eigen function means, so eigen functions of a quantum mechanics, it should have some properties. That the first property is that it should have single valued, it should be single valued, that your wave function psi, what you consider it is a psi. And the second one is that it should remain finite everywhere. It should remain finite everywhere. And also the third one is their first derivative, okay, with respect to their variables, their first derivative with the derivative, how to do it, they you have to do it with respect to their variables, are continuous everywhere. So the functions which satisfy all these conditions, which should be a single valued, which is remain finite everywhere, and their first derivative with respect to their variables are continuous everywhere, are called as, which satisfies all these functions are called as eigen function. Okay, so eigen functions. So the wave function which satisfies the above properties are solved for certain value of energies. I said it here, you can see here, it is calculated only when x is equal to 0 and x is equal to L. So you cannot calculate it for all the values, it can be calculated only for the discrete values. Okay, it is not continuous. So how do you calculate that? We calculate it using certain rules that are provided by quantum mechanics. Who formulated this quantum mechanics rules? See, I said that one is Max Born, Erwin Schrödinger. These guys, there are many other guys, but these two guys are very prominent in formulating many of your quantum mechanics rules. Okay, so quantum mechanics. So the rule, so here what are the rules? I'll just tell you what are the rules. That the rule has a mathematical operator. So the rules are some mathematical operator that can be performed for a psi in a proper way. So now what is that called as? The specific type of, we can just say that the specific type of operator, okay, that is used for certain operation that is needed to be performed can be identified through what is known as operator. It is known as operator. So there are different operators. So the more about your operators you will learn in your higher classes, but still I can just say that all operators of quantum mechanics have eigen functions and eigen values. Here, as I said that what is your operator? Your operator is, you can see that here double differentiation you have, that itself is your operator. So now for an example, what is operator to say? So here suppose you assume that root 5 is a number. So now what is the operator? Operator is 5. So what does the operation of root? Take the square root. So this is a simple operator. But in quantum mechanics it should be proper values function. So now suppose you have d by dx of x square plus 5x. So here what is the operator? D by dx. What does it do? It says that take a differentiation with respect to x. Now suppose you have x cube into dx. So here what does it says? That integrate with respect to dx with respect to x. So these are the kind of operators what I am talking about here. So quantum mechanics also has certain rules for the mathematical operations, so that they are called as operator. Suppose you have your position vector. Okay, so here suppose you have your position, dynamic variable is position vector r. So the symbol is r, operator representation is r cap is equal to r. Suppose linear momentum is there. Linear momentum, that is linear momentum, I can write it by simple p. The operator notation I can just write it p cap, which means that h by I delta. If you see this p cap, you have to differentiate h by I, you have to write it, and delta you have to write it. Okay, suppose if you have your energy operator. So energy operator means now it is represented by E. So h cap. Suppose if you see that any derivation here in your derivations, I will show you some of the derivations there, where if you just see h cap, which means that you have to operate with respect to energy. So that is given by IH by 2 pi dou by dou t. This is an energy operator. So suppose you have to write Hamilton